These are the landmines of World War II, from terrifying anti-tank giants to ingenious anti-personnel killers. Let's start with the anti-tank mines. The Landmine, plate mine in German, was the definitive anti-tank weapon of the war. Shaped like a dinner plate and packed with 5.5 kilograms of TNT, it required roughly 200 pounds of pressure to detonate. That meant infantry could walk right over it, but tanks couldn't. German engineers buried millions across North Africa, Italy, and the Eastern Front. Rommel's forces laid them in elaborate patterns at El Alamein, creating killing zones that slowed Allied armor for weeks. The design was so effective that Allied engineers studied captured examples and adapted the concept for their own mines. Simple, brutal, and devastatingly reliable. America's answer to the Landmine was the M1, a heavy, circular mine containing 6 pounds of TNT. Introduced in 1942, it could crack a tank's belly armor or blow off a track, immobilizing the vehicle. GIs called it reliable but heavy. At 20 pounds, hauling them into position was backbreaking work. Engineers often stacked two M1s together for extra punch against heavier German panzers. Over 3 million were produced, making it one of the most widely deployed American ordnance items of the war. The TM-41 was the Red Army's standard anti-tank mine, a rectangular metal box containing nearly 4 kilograms of explosive. Soviet factories churned out millions despite constant German bombing. What made the TM-41 remarkable was its simplicity. Wooden versions were produced when metal became scarce, invisible to German mine detectors. At Kursk in 1943, Soviet engineers laid over 1 million mines in defensive belts, creating the densest minefields in history. German tank crews learned to dread the soft click that preceded catastrophe. Anti-tank mines stopped armor, but infantry needed different weapons. Next, the anti-personnel mines that made every footstep dangerous. This was terror engineering. When triggered, the S-mine didn't explode in the ground. It launched itself 3 feet into the air before detonating, spraying 360 steel balls at waist height. American GIs called it Bouncing Betty. The Germans called it the shrapnel mine. A single mine could wound or kill everyone within 20 meters. The distinctive pop of the propellant charge became one of the most dreaded sounds of the war. Over 1.9 million were produced, and clearing them cost countless engineer lives. The M2 was a pressure-detonated fragmentation mine, simple, cheap, and lethal. Weighing just over 3 pounds, it could be deployed rapidly by infantry units establishing defensive perimeters. The cast-iron body shattered into hundreds of fragments upon detonation. In the Pacific, Marines used them to protect beachheads from Japanese night infiltrators. The M2's reliability in jungle humidity and beach sand made it invaluable, though its small size meant it was often difficult to locate after battles ended. Not technically a mine, but used like one. The Hawkins was a flat, rectangular anti-tank grenade that could be buried in roads or thrown under vehicles. British engineers loved its versatility. At just over 2 pounds, soldiers could carry several into battle. It could be triggered by pressure, pull wire, or even crushed by a vehicle's weight. Production exceeded 6 million units. Cheap, adaptable, and effective, the Hawkins proved that sometimes the simplest solutions work best. Japanese mine doctrine emphasized concealment over sheer explosive power. The Type 93 was a small, wooden-cased anti-personnel mine, virtually undetectable by metal detectors. Buried along jungle trails in the Pacific, they caused steady casualties among advancing Allied troops. The wooden construction reflected Japan's material shortages, but turned into a tactical advantage. American engineers had to probe every inch of ground by hand, slowing advances to a crawl. The POMZ-2 was a fragmentation mine mounted on a wooden stake, activated by tripwire. Cheap to produce and easy to deploy, Soviet forces planted them by the thousands around defensive positions. The cylindrical cast-iron body would fragment into deadly shrapnel when triggered. Its above-ground mounting made it effective in snow, a critical advantage on the Eastern Front where buried mines often froze solid and failed to detonate. These specialists covered battlefields across every theatre. But as the war dragged on, desperation bred stranger designs. When metal became scarce, German engineers turned to glass. The Landmine 43 was an anti-personnel mine with a glass body and minimal metal components, nearly invisible to Allied mine detectors. The glass shattered into razor-sharp fragments upon detonation. British and American engineers called them nightmare mines because the only way to find them was careful probing by hand. Production numbers remain uncertain, but captured examples showed remarkable ingenuity under resource pressure. Another material shortage solution. The Topf mine was an anti-tank mine made almost entirely of pressed cardboard and tar. Only the detonator contained metal. Packed with a potent explosive mixture, it could still destroy a tank's track. But moisture was its enemy. In wet conditions, the cardboard casing often degraded, making the mine unstable or ineffective. Tens of thousands were produced in 1944-45, reflecting Germany's increasingly desperate resource situation. A dedicated anti-tank mine version of the Hawkins grenade, the number 75, was designed for rapid deployment from moving vehicles. Engineers could scatter them from trucks retreating ahead of advancing armor. Instant minefield. The design included a distinctive crush fuse, activated by a tank's weight. Over 4 million were manufactured, and they remained in British service well beyond the war's end. These oddities showed how material shortages drove innovation, sometimes brilliant, sometimes desperate. But the catalogue isn't complete without the overlooked designs. Introduced late in the war, the M7 was lighter and faster to deploy than the M1. At just £5, paratroopers could carry them during airborne operations. The trade-off was reduced explosive power, effective against lighter vehicles but marginal against heavy tanks. Still, its portability made it valuable for rapid defensive positions during the fast-moving final campaigns in Europe. The PMD-6 was simplicity itself, a wooden box containing a 200-gram TNT charge triggered by a simple pressure plate. Undetectable by metal detectors and cheap enough to produce by the millions, it represented the opposite end of mine design from the complex S-mine. No sophistication, no bouncing mechanism, just a hidden explosive waiting for a footstep. Soviet engineers taught partisans to build them from local materials, crude but effective.